Okay, moving on to the next chromosomal abnormality. We have two left, chromosomal rearrangements and deletions / microdeletions. So chromosomal rearrangements, aka translocations. So around 1 in 400 have structural / chromosomal rearrangements. If two chromosomes get close together, the genes can switch over, which equals a translocation. There are various types of translocation, so there's three main types. Number one, balanced. Here there's no net gain or loss of genetic material. No net gain or loss of genetic material. So for example, we're swapping of genetic material between chromosome 3 and 10, but no genes are lost, and there's equal exchange of material. This should not give any problems, as we still have the same number of genes, just in a different order. So it shouldn't give any problems, we still have the same number of genes, just in a different order. The cell doesn't care where the gene is located, as long as it's there, or just that it's there. Number two, we have unbalanced translocation. Here there is a net gain or loss in genetic material, so there's an unequal change of genetic material. So in the balanced one, there's an equal change in genetic material. Here, unbalanced, there's an unequal change of genetic material. So this therefore results in extra or missing genes. So as we can see, here's balanced, here's unbalanced, there's extra, here, extra and missing genes. If this occurs in somatic cell, there's no effect, as there's still the same number of genes. If this occurs in gametes, this is a big problem, as offspring may have gained or lost genes. The third type and final type is Robertsonian, so Robertsonian translocations. These translocations involve certain chromosomes called acrocentric chromosomes. So Robertsonian translocation involve acrocentric chromosomes. So chromosomes are made up of a short arm, which is P, a long arm, which is Q, and how I remember that is that how I remember P is short arm and Q is long arm is that Q. If you draw a Q, it takes you longer to draw a Q, as there's more lines basically, and the lines of the Q are longer than the lines of the P. So Q is long arm, P is short arm. So acrocentric chromosomes are have a very short P arm and a very long Q arm. An exchange between two acrocentric chromosomes is a Robertsonian translocation. So here we see a acrocentric chromosome has a very long Q arm and a very short P. An exchange between two acrocentric chromosomes is called Robertsonian translocation. For example, chromosome 13 and 14 may exchange genetic material with a long arm of chromosome 13 joins the long arm of chromosome 14, giving a long chromosome. This is called a Robertsonian 13-14 chromosome. So imagine this is chromosome 13, this is chromosome 13, this is chromosome 14. This would be Robertsonian 13-14 translocation. The P arm / short arm are so short that they get lost, as P arms don't code for repetitive sequences. So this P arm or this fragment, my god, I don't know. This P arm or this fragment gets lost. The P arm or the short arm are so small that they are lost. Easy peasy. This does not affect the person, as they still have the right amount of genetic material, but the children may have a problem. So Robertsonian translocation does not affect the person, as they still have the right amount of genetic material, but the children may have a problem, as they may have abnormal number of chromosomes. So if a Robertsonian translocation occurs in a somatic cell, no problem, as you still have the same number of chromosomes. If it occurs in the gamete, this could be a potential big problem. So the possibilities for the child are 4. Number 1, combinations can be lethal, which are miscarriage. There may be a trisomy, for example, Down syndrome. There may be the same Robertsonian translocation. They may have the same Robertsonian translocation, so they may be a balanced carrier, or they may receive the normal chromosomes. I'm going to try and show you a picture, because you're probably thinking, okay, what's a balanced carrier? But I'll try to show that to you now. So here is a balanced carrier. So here we can see Robertsonian. We have 4 options: either potentially lethal. Yeah, either they have the trisomy, which is here, trisomy for Down syndrome. Either they are normal or they're a balanced carrier. And a balanced carrier means that they still have both chromosomes, but they're carrying the Robertsonian chromosome as well. And if you don't understand that, then no issue, just try research it, inshallah. So, deletions/mutations. This is the final chromosomal abnormality. So deletions are areas of chromosomes that can also occur. Deletions of areas